if A bar, B bar, C bar non-coplanar vectors, if A bar, B bar, C bar non-coplanar vectors, all non-coplanar vectors will be linearly independent. X comma y belongs to R, two scalars, such that A bar plus B bar plus C bar is equal to 1 by x times of D bar, and B bar plus C bar plus D bar is equal to 1 by y times of A bar. And then what is the value of 1 by xy times of A bar plus B bar plus C bar plus D bar? This is a problem based on the linear combination. I will repeat the question. A bar, B bar, C bar non-coplanar vectors in a plane, x comma y will be the real numbers, and this satisfies the relation A bar plus B bar plus C bar is equal to 1 by x times of D bar, and B bar plus C bar plus D bar is equal to 1 by y times of A bar. Then what is the resultant value of 1 by xy times of A bar plus B bar plus C bar plus D bar, provided the given condition A bar, B bar, C bar being non-coplanar vectors. First given that A bar plus B bar plus C bar will be is equal to 1 by x times of D bar. First relation, B bar plus C bar plus D bar is equal to 1 by y times of A bar. Second relation, adding both the relation, we noticed that on subtracting, second polynomial minus 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 minus. So B bar C bar on cancellation, A bar minus D bar will be is equal to 1 by x times of D bar minus 1 by y times of A bar. Condition A bar, B bar, C bar, D bar non-coplanar. Non-coplanar vectors are linearly independent. When we wrote into the linear combination A bar plus 1 by y times of A bar plus minus D bar minus 1 by x times of D bar, and will be is equal to 0 bar. On taking A bar common, it will be 1 plus y. On taking D bar common, it will be minus 1 minus 1 by x is equal to 0 bar. As A bar, B bar, C bar, D bar non-coplanar, all non-coplanar vectors are linearly independent, their linear combination equal to 0. In the sense each scalar will be is equal to 0, means you can able to put 1 plus y is equal to 0 or minus 1 minus 1 by x is equal to 0. Then we noticed that 1 plus 1 by y is equal to 0, 1 by y is equal to minus 1, this leads y is equal to minus 1, okay, or minus 1 minus 1 by x is equal to 0, 1 by x is equal to minus 1, x is equal to minus 1. Substituting x equal to minus 1 in the first relation or substituting y is equal to minus 1 in the second relation, we got that A bar plus B bar plus C bar is equal to minus 1 times of D bar. Substituting x is equal to minus 1 in the first relation, we got the resultant answer A bar plus B bar plus C bar plus D bar is equal to 0 bar. Therefore, the value of 1 by xy times of A bar plus B bar plus C bar plus D bar is equal to 1 by xy into 0 bar, which is null vector 0 bar. So, the value of 1 by xy times of A bar plus B bar plus C bar plus D bar is equal to 0 bar. And it is linearly independent vectors based problem, where A bar, B bar, C bar being non-coplanar. Non-coplanar vectors are linearly independent. When their linear combination is equalated to 0, each scalar equalated to 0, we eliminated the value of x and y and substituted in the combination. So, this is problem based on the linear combination. Next, Take another problem. In the Cartesian plane xy, O is the origin. Consider a person starts at origin, walks 3 units in northeast direction and reaches to P. From P, he walks 4 units distance parallel to northwest. From P, he walks 4 units distance parallel to northwest direction and reaches to point Q. Express OQ bar in terms of Ij, in terms of I bar j bar, given that angle XOP is equal to 45 degrees. In the Cartesian plane x comma y, O is the origin with respect to the Cartesian coordinate axis. A person starts at the origin O, walks 3 units in the northeast direction. Generally, this will be the north, south, east and the west. So, he walks in the northeast direction, north, south, east and west. A person walks 3 units in the northeast direction and reaches to point P. From P, he walks 4 units parallel to northwest direction. From there, northwest direction parallel to 4 units and reaches to point Q, another point Q. Then express OQ bar in terms of I bar and j bar, where given that angle XOP is equal to 45 degrees. Last session explained to you I bar j bar are the unit vectors of x axis and y axis. They are the unit vectors of x axis and y axis. Now take the system, rectangular Cartesian system, north, y axis positive, south, east and the west, O be the origin, or you called it is x axis and y axis, xy plane direction. I bar is the unit vector of x axis and j bar is the unit vector of y axis. Now the question, a person starts from the origin, walks 3 units in the northeast direction, he moves 3 units and reaches to a point P, OP, the movement of the person OP. From P, he walks 4 units distance parallel to northwest direction, this is northwest direction, and moves 4 units in the northwest direction. As it is a northwest, this will be 90 degrees perpendicular, northwest direction 4 units and reaches to point Q, this is Q. Then express OQ bar, the vector OQ bar in the coordinate axis unit vectors I bar and j bar, given that angle XOP is equal to 45 degrees. This is the notation with respect to the addition of the vectors in the coordinate system. So, in order to calculate OQ bar, first we will try to calculate OP bar. OP bar in the direction of the northeast, you draw a perpendicular from P to x axis, let OP bar, let P point as x comma y, x units and y units. So, this is perpendicular drawn to the x axis, x units and y units. So, the position vector of OP bar is equal to, x times of I bar plus y times of j bar. Calculate x value, y value. As it is a right angle triangle, applying the Pythagoras theorem, here 3, 4, this will be 5. Mod of length of OQ bar will be 5. Now, in order to calculate OP bar, magnitude of OP bar 3, because it is already 3 units from the origin, OP bar will be 3. To calculate the position vector of P, OP bar is equal to x times of I bar and y times of j bar. In order to calculate x and y, So, PM is a perpendicular drawn from P to x axis. In triangle OPM, take triangle OPM, cos 45 degrees will be is equal to adjacent divided by hypotenuse, that is x divided by 3. This leads x is equal to 3 divided by root 45. Cos 45 equal to 1 by root 2. And in the same triangle consider sin 45 degrees. Sin theta will be is equal to opposite divided by hypotenuse, that is equal to y by 3. So, the value of y is equal to 3 divided by root 2, and expressed components of x and y with respect to 45 degrees and the magnitude of OP bar in terms of 3 by root 2 and 3 by root 2. Therefore, the position vector of OP bar will be is equal to 3 by root 2 times of I bar plus 3 by root 2 times of j bar, expressed OP bar in terms of Ij. Now, we have to express OQ bar in terms of I and j, where I and j will be the unit vectors of x axis and y axis. Draw a projection from Q to x axis, that is QL. A projection is drawn. QL is perpendicular drawn to x axis, and already we took this is x and y. Now, this length I wanted to take x1 and y1. So, OQ bar will be is equal to x1 times of I bar plus y1 times of j bar. We took ordinates of q as x1, y1. So, OQ bar, its magnitude already fine. OQ bar is equal to OX1, x1 times of I bar and y1 times of j bar. Now, expressing x1 and y1 in terms of their cosine of the angles and sine of the angles. For that, the rest of this angle I wanted to take an alpha. Okay. In triangle OPQ, as it is a right angle triangle, so cos alpha will be is equal to cos alpha will be is equal to 3 divided by 5, adjacent divided by hypotenuse, and sin alpha is equal to opposite divided by hypotenuse, that is 4 by 5. So, in triangle OPQ we calculated sin alpha, cos alpha. Now, the value of OQ bar to calculate. Now, in triangle OQL, the complete angle will be is equal to cos alpha plus 45 degrees. Cos alpha plus 45 will be is equal to x1 divided by OQ, that is fine. Cos alpha plus 45 is equal to x1 plus 5. This implies x1 is equal to 5 times of cos alpha plus 45 degrees. And similarly, sin alpha plus 45 degrees will be is equal to sin alpha plus 45 will be opposite by hypotenuse, that is y1 divided by 5. So, y1, this implies y1 is equal to 5 times of sin alpha plus 45 degrees, and we have expressed with the help of triangle OPQ and triangle OPM cos alpha sin alpha calculated, then x1 by 1 expressed in terms of the cosine of the angle, sine of the angle. Now, OQ bar will be is equal to x1 in the sense 5 times of cos alpha plus 45 degrees into I bar, x1 into I bar plus 5 times of sin alpha plus 45 degrees into j bar. Simplify, that is equal to 5 as we took common, it will be cos alpha cos 45 degrees minus sin alpha sin 45 degrees into I bar plus sin alpha cos 45 degrees plus cos alpha into sin 45, substituting the value of sin alpha cos alpha, which is 5 times of cos alpha. What is cos alpha? That is 3 by 5. 3 by 5 into cos 45, 1 by root 2 minus sin alpha. Sin alpha is equal to 4 by 5 into 1 by root 2 times of I bar. and plus sin alpha will be 4 by 5 into 1 by root 2 plus cos alpha, that is 3 by 5 into 1 by root 2 times of j bar, and which is nothing but 5 cancel, 3 by root 2 minus 4 by root 2, that is minus 1 by root 2 times of phi bar plus 4 by root 2 3 by root 2, that is 7 by root 2 times of j bar. So, we have expressed OQ bar is equal to minus 1 by root 2 times of phi bar plus 7 by root 2 times of j bar with the help of the geometrical concept calculating the position of vector of OQ bar in the coordinate system. So, now take another problem. If the position vectors of A and B are 3i bar minus 2j bar plus k bar and 2i bar plus 4j bar minus 3k bar. Position vectors of A, B are 3i bar minus 2j bar plus k bar and 2i bar plus 4j bar minus 3k bar are position vectors of 2 points. Then find the length of AB bar. What is the length of AB bar vector? The position vectors of A bar and B bar given by 3i bar minus 2j bar plus k bar and 2i bar plus 4j bar minus 3k bar. Then find the length of AB bar. So, given that connected to the rectangle ordinate system, OA bar is equal to 3 times of phi bar minus 2 times of j bar plus k bar, and the position vector of P, OB bar is equal to 2 times of phi bar plus 4 times of j bar minus 3k bar. So, find the length of AB bar, magnitude of AB bar. So, to get the magnitude of AB bar, first calculate the position vector of AB bar. So, position vector of AB bar is equal to position vector of B bar minus position vector of A bar, in the sense OB bar minus OA bar. Take the position vectors, and that is 2 times of phi bar plus 4j bar minus 3k bar minus OA bar 3 times of phi bar minus 2 times of j bar plus k bar. Finding the position vector of AB bar, then go for its magnitude. As I bar, vector addition, 2i bar subtracted by 3i bar, that is minus I bar, 4j bar subtracted and subtracted, that will be 6 times of j bar, minus 3k bar and minus k bar, minus 4 times of k bar. So, this is the position vector of AB bar, but we want length of the AB bar. Just now I told you, if R bar is equal to x times of I bar plus y times of j bar z times of k bar, mod of R bar, its length is equal to root over x square plus y square plus z square. Apply this formula in the length of the above vector, modulus of AB bar. So, mod of AB bar will be is equal to square root of minus 1 whole square plus 6 whole square plus minus 4 whole square, and which is nothing but square root of 1 plus 36 plus 16, which is 37 plus 16, 3 and 1, 4, root over 53 units. We are not bothered about AB, just length of the AB is equal to root of 53 units. Okay. Next, and it is a problem calculating length of the vector. Take another problem based on the parallelogram law. Sides of a parallelogram are given by 2i bar plus 4j bar minus 5k bar. Sides of a parallelogram are 2i bar plus 4j bar minus 5k bar and I bar plus 2j bar plus 3k bar. Then find a unit vector parallel to one of the diagonal. Find a unit vector parallel to one of the diagonal, unit vector parallel to one of the diagonal. Here sides of a parallelogram are given, then find a unit vector parallel to one of the diagonal. In the vector algebra there is one problem, sides also triads, points also triads. There is only the one problem in the vector algebra, sides also given triads and the points also triad. Here the given problem, sides of the parallelogram, consider, let A bar B bar are adjacent sides of a parallelogram. First we will find their vectors. A bar B bar are the adjacent sides of a parallelogram. You draw one parallelogram A, B, C, D. A bar, B bar. Then here the question, find the unit vector of the diagonal, one of the diagonal. It may be first take the diagonal vectors and its unit vector. So in this ABCD parallelogram, what will be the diagonal? AC bar is one diagonal and BD bar will be the other diagonal. So the diagonal AC bar will be is equal to, diagonal AC bar will be is equal to AB bar plus BC bar, and that is nothing but A bar plus B bar, its unit vector AC bar cap, AC cap is equal to A bar plus B bar divided by mod of A bar plus B bar, unit vector of the diagonal AC bar. Next BD bar, second diagonal, BD bar, diagonal BD bar, diagonal BD bar will be is equal to BC bar plus CD bar. Already BC bar will be B bar and CD bar will be opposite direction of A bar, that is minus A bar. So it will be BC bar will be is equal to B bar and CD bar is equal to minus A bar. Unit vector of BD bar, BD cap is equal to B bar minus A bar divided by mod of B bar minus A bar. But here find a unit vector, one of the diagonal, you may take AC bar or BD bar. Now this is construction of the parallelogram with unit vectors of the diagonals. Now here given that 2I bar plus 4J bar minus 5K bar, I bar plus 2J bar plus 3K bar are the sides of the parallelogram. You draw one parallelogram ABCD and take their sides A, B, C and D. Their sides are given by AB bar is equal to 2I bar plus 4J bar minus 5K bar, and the second adjacent side will be BC bar, I bar plus 2J bar plus 3K bar. In order to find the unit vector of the diagonal, first find the diagonal vector. So the diagonal vector AC bar will be is equal to AB bar plus BC bar, and the diagonal AB bar will be 2 times of I bar, 4 times of J bar minus 5K bar added with BC bar, I bar plus 2J bar plus 3K bar. So the diagonal vector will be 3 times of I bar plus 6 times of J bar minus 2 times of K bar, AC diagonal. Okay. Now after getting the AC diagonal, it's a unit vector. So AC cap will be is equal to AC bar divided by mod of AC bar in the parallelogram same, which is equal to 3 times of I bar plus 6 times of J bar minus 2K bar divided by its magnitude root over 9 plus 36 plus 4, and that is nothing but 3I bar plus 6J bar minus 2K bar divided by 49 root over 49, which is equal to 7. 1 by 7 times of 3I bar plus 6J bar minus 2K bar. This is the diagonal AC bar, but here find the unit vector any one of the diagonal. This is first diagonal AC bar. Now we will find the other diagonal. So to get the other diagonal, calculate the other diagonal vector. What will be the other diagonal? As we took AB bar is equal to 2I 4J minus 5K, AB bar equal vector, that is DC bar. DC bar is equal to 2I bar plus 4J bar minus 5K bar in the same direction, and AD bar parallel to BC bar, that is I bar plus 2J bar plus 3K bar. Okay. Now I wanted to find the other diagonal BD bar. Find the BD bar diagonal, then go for its magnitude vector. So the diagonal BD bar is equal to BC bar, the side BC bar plus CD bar, which is BC bar. The diagonal BC bar will be I bar plus 2J bar plus 3K bar plus CD bar, opposite direction of the, because this is DC bar. When we took opposite direction, then it will be minus 2I bar minus 4J bar plus 5K bar. First we are finding the diagonal BD bar and its magnitude vector. BC bar plus CD bar, I bar subtracted by 2I bar, that is minus I bar, 2J bar subtracted by 4J bar minus 2J bar, 3K bar subtracted by 5K bar, minus of minus plus, which is 8 times of K bar. This is the diagonal BD bar, but my question, find a unit vector, one of the diagonal, either AC bar or BD bar. So BD cap will be is equal to BD bar vector divided by mod of BD bar, a unit vector along any one of the diagonal, AC bar or BD bar. So which will be is equal to minus I bar minus 2J bar plus 8K bar BD vector and its magnitude, that is root over 1 plus 4 plus 64. So the diagonal vector of BD bar will be minus I bar minus 2J bar plus 8K bar divided by root 69. It is not a perfect square, limit 68 plus 1 69. We calculated the diagonal vector of first one and the second one. The diagonal of a parallelogram ABCD intersect at E. You draw one parallelogram ABCD. Diagonal of a parallelogram ABCD intersect at E. A, B, C, D. The diagonal of a parallelogram ABCD intersect at E. You draw the intersection of the diagonal AC bar and BD bar. They intersect at E. The diagonal of a parallelogram ABCD intersect at E. O is the origin in the reference. So you may take O outside or inside or on the diagonal or on the parallelogram. O is the origin somewhere. O is origin. If the position vector of A is A bar, the position vector of A is A bar, the vector AB bar is equal to P bar, and the vector BC bar is equal to Q bar. BC bar is equal to Q bar. Here vector A bar, OA bar is equal to A bar. The vector AB bar is equal to P bar and the vector BC bar is equal to Q bar. Then express the vector OE bar, point of intersection of the diagonals, in terms of ABP. I will repeat the question. The diagonals of a parallelogram ABCD intersect at E. E is the point of intersection of the diagonals. O is the origin, reference to the above parallelogram. If the position vector of A is A bar and AB bar is equal to P, BC bar is equal to Q, then express OE bar in terms of A bar, P bar, Q bar. So calculate the point of intersection of the diagonals, where E is the point of intersection of the diagonals. Already we know that in a parallelogram diagonal bisects each other. So OE bar is equal to OA bar plus OC bar divided by 2. So find the position vector of OA, OC, then take the midpoint. So in order to calculate the OA bar already given, we need OC bar. OC bar is nothing but AC bar. So to calculate AC bar, given that AB bar and BC bar. So AB bar will be is equal to P bar. So AB bar can be written as OB bar minus OA bar is equal to P bar. Already OA bar, A bar given, substituting. So OB bar minus A bar is equal to P bar. OB bar is equal to A bar plus P bar. This is the position vector of P, B, that is A bar plus P bar. Next, to get C bar, given that BC bar is equal to Q bar. Again express BC bar into the position vector. BC bar is equal to OC bar minus OB bar is equal to Q bar. So OC bar is equal to OB bar plus Q bar. Put the value of OB bar. So OC bar is equal to OB bar is A bar plus P bar plus Q bar. This is OC bar. Position vector of AC bar. A bar plus P bar plus Q bar. And with the help of origin A bar, B bar, expressed A bar and C bar in terms of P and Q. Now in order to calculate E is the midpoint of OA bar and OC bar. So OE bar is equal to OA bar plus OC bar divided by 2. And that is OA bar already given A bar, OC bar we calculated, that is A bar plus P bar plus Q bar and divided by 2. So the position vector of OE bar is equal to 2 times of A bar plus P bar plus Q bar divided by 2. We expressed midpoints of the diagonal in terms of the vertices as well as the sides, where A is the vertex and P and Q are the sides, and expressing midpoint of the diagonal in terms of the vertices and the sides.